Hi there students, how are you doing? Today we're going to look at the side-side-side triangle congruence theorem, and we're going to do this in two ways. First, I'll show you how to construct a triangle using the Desmos geometry tools and given three sides. Then we'll do a second triangle and we'll see if we can use the transformations that we know to make those two triangles coincide. Let's jump into this. First of all, to construct a triangle, I've given myself side AB, side BC, and side CA. So these are the three sides of my triangle, and notice what I'm going to try to do is get these to match up and build a triangle. To do this, the first step is going to be to use my compass tool. I'm going to grab the length of AB and just grab a point somewhere in the plane here, and we'll mark off this circle with the radius of AB, and this will be the side that corresponds with AB. Notice that the size of this circle is linked to the length of AB, and let's go ahead and add some labels to this. So let's call this one D, and let's call this point E. So the next step is that I want to find the lengths BC and AC that are going to come off the two sides here. To do this, what I'm going to do is, first of all, hide this circle, because I don't need you anymore. Not delete it, but hide it, so it's still there controlling the construction. And second, I'm going to use that compass tool again, and go over here to BC, and I'm going to bring that down. Remember that this point E corresponds with B, so I'll put that here. And then I'll use the compass tool again, and remember that point A corresponds with D. Locate that here. And this tells me that the third point of this triangle could be here or could be here. Doesn't matter. You say tomato, I say tomato. I'll put it down here. And we can draw this triangle. Notice that the three sides of this triangle are now linked to the three lengths of the given AB, BC, and CA. So I've just created this new triangle. I'll go ahead and hide these two circles because I don't need them. And watch as I drag one side, the triangle will change. Now the question is, if I build a second triangle using the same process, will it be exactly congruent to this first one, to DEF? Let's take a look. So I'm going to do this same construction once more time with three more points. Okay, there we go. Let's put some labels on those points. So now notice that point D corresponds with G, E corresponds with H, and I corresponds with F. So by the way I've constructed these, we can look at whether or not these two triangles are congruent. We could try to align the points. And what's interesting here is that you're noticing I'm having a bit of a difficulty because these two triangles are in fact reflections of each other. So I can't get them to line up exactly on top of each other. However, I could imagine doing some transformations and seeing whether or not these correspond. So on the transformations, for example, I could define a translation. I'm going to choose from D to G. And then it says select some objects to apply this translation to. So I'll go ahead and select this whole triangle down here. Oops, but not point G. And say apply. And there's my transformed triangle. Next I can do the same thing and do a transformation which is a reflection. And it says choose the line of reflection. I'll choose this one here. Oh, I made a mistake. Let's try that again. Delete that one. So I'll try that reflection again. Choose the line of reflection. Got it. And now it says choose some things to reflect. So I'll reflect this, and this, and this, and we'll apply. And now we notice that under these transformations, in fact, these two triangles are congruent. And notice that I can change everything here and everything corresponds. In other words, I can change my original lengths and everything still corresponds. So my transformed points work.